Welcome back to AI for Product Managers. I am Pranav and this is episode 2. If you watched episode 1, you know how you know now you know the four types of AI and the five question framework, right? Today we are going a bit deeper. Here is the uncomfortable truth. You know, your agile process is lying to you. Those nice 2 week sprints, those predictable velocity charts, those clear acceptance criteria, they all break down the moment you start building AI products. You know that 87% of AI projects never make it to production. Not because the technology doesn't work, but because teams try to manage AI like traditional software, you know, and they plan like they know what's going to happen. With AI you don't, right? So today I'm going to show you what actually works, the AI product lifecycle, experiment driven development, and how to plan sprints when you genuinely don't know if the model will work. Let's get into it. So here's what we are covering in next few minutes. Like first, why traditional agile fails with AI, the specific ways it breaks down, and second is the six-phase AI product life cycle that actually works. The third thing is how to plan sprints when outcomes are uncertain. Fourth, the experiment-driven development model. This will change how you run your team, right? And fifth is like I'll show you a real sprint board from an AI team so you can see what this looks like in practice. So let's start with why everything you know about shipping software is about to get challenged. Yeah. So let me paint the picture. In traditional software, you write a spec, engineers build it, QA test it, and you ship it, right? The outcome is deterministic. If you code it right, it works every time. With AI, nothing is deterministic. You train a model and it's 78% accurate. Is that good or bad? Depends on the use case, right? You can write an acceptance criteria that says model works correctly because it's always uh, wrong some percentage of time, right? Traditional software has predictable timelines. You have built login pages before. You know it takes a week. Uh, and AI, you need spend 3 weeks training a model and discover your data is garbage, right? Back to square one. In traditional software, done is binary. The button works or it does not. In AI, done is a spectrum, you know. The model is 82% accurate, ship it. Wait for 85% or 90%. That's a product decision, not an engineering decision. And here is the killer. In traditional software, you spend maybe 20% of time on requirements and 80% on building. In AI, you spend 70% of your time on data, collecting it, cleaning it, labeling it, and only 10 to 20% on the actual model. Most PMs don't plan for this. So if Agile doesn't work, what does? Let me show you. Before I show you the life cycle, I need you to internalize three fundamental differences between AI and traditional software. These are not minor tweaks, they are paradigm shifts. No? Difference number one is uncertainty is the default. In traditional software, the question is how long will it take? In AI, the question is will it work at all? You know, you genuinely don't know if a model will achieve acceptable accuracy until you try. You can't spec your way to certainty, right? You have to experiment it. This means your planning has to account for failure, not failure as in the engineering made a bug, right? But failure as in the approach fundamentally doesn't work and when need to try something else. That's normal in AI. It's not a sign of bad team. The difference number two is data is a product. I cannot stress this enough. 70% of AI project time is spent on data, collecting it, cleaning it, labeling it, and validating it. Right? The model itself, that's maybe 10% of the effort. If you are PM planning for an AI project and you know and you don't have a data strategy, you don't have a project, right? I have seen teams hire ML engineers before they even have clean data. That's like hiring a chef before you have ingredients, right? That the data is the product, the model is just the recipe. And the difference number three is like done is a spectrum. Traditional software, the feature works or it does not. AI is the model. In AI, the model is like 78% accurate. Is that good enough? What about 82%, 88%, and 95%? There is always a trade-off between accuracy and time to market. And here is the thing: deciding a good enough is a PM's job, right? Not a data scientist, not the engineers. It's your job. These three shifts, uncertainty, data centricity, and threshold decisions, are why you need a different life cycle. Let me show you what it looks like. So let's start with what you know, the traditional product life cycle: discover, define, design, development, test, and launch. Right? This is linear, predictable. Each phase has clear inputs and outputs. You have done this 100 times, right? Now here is the AI product life cycle with six phases: problem framing, data strategy, model experimentation, evaluation and thresholds, production and MLOps, monitor and retrain. Okay. The four critical differences from traditional is like one, it's not linear. You will loop back. You'll get to evaluation, realize your data has issues, and go back to phase two. Right? That's not failure. That's the process. In phase 2 and 3, data and experimentation takes 60 to 70% of total project time. If your Gantt chart shows these as small boxes, your Gantt chart is wrong. You know, in phase 4, the evaluation requires PM judgment. The data scientist can tell you the model is 82% accurate. Only you can decide it if that's good enough to ship or not. Right? In phase 6, it never ends. Unlike traditional software that you ship and maintain, AI models degrade over time, user behavior changes, data drifts, the world changes. You need ongoing monitoring and retraining forever. Let me walk you through each phase in detail. The phase one is problem framing, right? So, this is where most AI projects go wrong. Not because the technology fails, but because the problem was poorly defined. In traditional PM, you might write, as a user, I want personalized recommendations. That's fine for a feature spec, but for AI, it's useless. You need to be surgical. The question one is, what exactly are we predicting, classifying, or generating? Not use AI for retention, but predict which users will churn within 30 days with at least 80% of precision, and see the difference. One is a wish, the other is testable hypothesis. And question two, what does success look like as a number? 85% precision or 90% recall, a 15% lift in click through rate? If you can't put a number on it, you can't evaluate whether the model works or not, right? In question three, what's the baseline without AI? If your current rule based system catches 60% of fraud, and your AI model catches 65%, is that worth the investment? You need to know what you are beating, right? And the question for, what's the cost of being wrong? A wrong product recommendation is mildly annoying. A wrong fraud detection flag blocks a legitimate customer and they leave forever, right? The cost of errors determines how accurate you need to be. And question five is there a simpler non AI solution? This is the most important question and the one PM skip most often, right? If a simple rule like flag transactions over $5,000 catches 80% of fraud, maybe you don't need an ML at all, right? AI should be the last resort, not the first. Spend real time on this phase. A well-framed problem is half the solution. And phase two is data strategy. And this is where I see most PM failures, not because PMs are bad at data, but because they don't realize how much time this takes. Here is the reality: 70% of AA project time is spent on data. Let me break that down: 25% on data collection, finding and assessing uh, the data you need, right? So 25% on data cleaning, handling missing values, fixing errors, normalizing the formats, right? And 20% on data labeling. Someone has to tell the model the model what correct look like, right? And only then do you get to the model training, which is maybe like 10% of the work. As a PM, here is your data checklist. Do we have enough data for machine learning? You need thousands of examples in minimum, right? For deep learning, millions. If you have 200 labeled examples, you don't have an AI project. You have a data collection project. Is it labeled? Someone needs to tag each example with the correct answer. What does that? How much uh, does it cost? For some problems, labeling requires domain experts, doctors, lawyers, fraud analysts, and that's too expensive, right? And is it representative? If your training data is all from one demographic, your model will be biased. If it's all from one time period, it won't generalize, right? Bias in, bias out. And is it fresh? User behavior changes. A model trained on 2023 data might be useless in 2026. How often does your data need refreshing, right? And can we legally access it? GDPR, CCPA, industry regulations. Can you actually use this data for training? This kills more AI projects than technical challenges. And finally, how do we get more data over the time, right? The best AI products have a data flywheel. Every user interaction generates new training data. Plan for this from the day one. Yeah. The phase three is where the traditional PM planning completely falls as apart. This model is experimentation, and it's fundamentally different from building the features. In traditional development, you know the outcome, build a login page, you know it's possible, you know roughly how long it takes. An AI experimentation you are running, scientific experimentation, you genuinely don't know if they'll work or not, right? The experiment loop has four steps: hypothesis, train, evaluate, and learn. Hypothesis is nothing like if we use model architecture X with dataset Y, will achieve Z% accuracy. This is your experiment ticket, not build recommendation engine, but test whether collaborative filtering on 6 months of purchase data achieves 3% click through lift, right? And train is like run the model on your training data. This might take hours or days depending on the model size and data volume. And evaluate, test on held out data the model has never seen. Measure your metrics. Did you hit your threshold or not, right? And learn what worked, what didn't, and why. This is most important step. Even failed experiments teach you something, right? Maybe the data is too noisy, maybe the architecture is wrong, maybe the problem is harder than you thought, right? So here is the mindset shift for PMs. You are not managing a backlog of features, you are managing a portfolio of experiments. Some will fail. That's not a bug, right? It's a process. Your job is to decide after this experiment, do we continue, pivot, ship what we have, or kill the project? Okay. And phase four is evaluation and thresholds. And this is the PM's most important job in the entire AI life cycle. You decide what's good enough to ship, right? Let me give you a concrete examples. A spam filter needs greater than 95% precision. And why? Because a false positive means a real email goes to spam, right? Your user misses an important message that unacceptable, right? So you optimize for precision even if you miss some spam. Okay. And product recommendation, you only need maybe 3% click through rate to be valuable, right? The cost of a bad recommendation is low, the user just ignores it, so you can ship at lower accuracy and iterate. And fraud detection needs greater than 99% recall. And why? Because missing a fraudulent transaction costs thousands of dollars. You'd rather flag some legitimate transactions for review than miss actual fraud. And coming to medical diagnosis, you need 99.5% plus sensitivity, right? Missing a disease is potentially life threatening, right? The threshold is set by consequences of failure, not by what's technically easy. And here is the rule: the threshold depends on the cost of being wrong, not the technical capability. A data scientist might say, we achieved 88% accuracy. Your job is to ask, is 88% good enough given what happens when we are wrong? Right? Sometimes 88% is amazing, sometimes it is not shippable at all. This is the product decision, not a technical decision. So own it. So phase 5 is like production and MLOps. Deploying an AI model is not like deploying a web app, right? It's a living system that needs constant care. Key decisions for PM is like, do you serve predictions in real time or batch? Real time means every user request hits the model, fast but expensive. Batch means you pre-compute predictions over the night, cheaper but still, right? You need a shadow mode strategy. Before going live, run your AI alongside the existing system, compare the results over, switch over when you are confident. Only switch over when you are confident, right? So you need a rollback plan. If the model starts performing badly in production, how fast can you revert to the old system? This should be instant, right? Not file a ticket and wait. And you need to think about cost. Every production cost compute, right? If you have million users making 10 requests each per day, that's 10 million model inferences. At even a fraction of cent each, that's add up fast, right? And phase 6 is monitor and retrain. And here is the training. Here is the um, uh, thing most like PMs don't realize: this phase was never ends, right? The traditional software does not get worse over the time. A login page that works today will work next year. AI models do get worse. It's called concept drift. User behavior changes, like COVID changed everything overnight. New products appear that the model never saw, right? Competitors change market dynamics, seasonal patterns shift. Your job as a PM: build monitoring dashboards from day one, set alerts for accuracy drops, schedule quarterly retrain cycles, budget for ongoing ML engineering. This is not a nice to have, but it's stakes, right? Yeah. So how do you actually run sprints for AI? I call it experiment driven development, or EDD. Let me show you the difference. So a traditional sprint ticket says, as a user, I want acceptance criteria Y, estimate, 5 pointer story, clear, predictable, and which is binary, right? As an AI experiment ticket says, hypothesis model X with data Y will achieve Z% of accuracy, right? The success criteria is metric threshold, confidence is medium, timeline is 1 to 4 weeks. Notice the timeline is a range, not a point, and the outcome is uncertain. and confidence is explicitly stated. So let me show you a real AI sprint board looks like. Instead of to do, in progress, done, you have a backlog, in experiment, evaluating, shipped, right? So this is the one. In the backlog, data collection tasks, research spikes. In experiment, we have active model training runs, evaluating experiments that finished but need PM decision, ship it, iterate, or kill it, shipped like experiments that met the thresholds and went to production. So notice that the cards are experiments, not features. Done means we learned something, not necessarily we shipped the code, right? A failed experiment that teaches you the approach won't work at all. That's a successful sprint. You learn fast and can pivot. Here is my 5 rule playbook for AI sprint planning. So the rule one is time box experiment, not outcomes. Say we'll spend 2 weeks on this, not we will achieve 90% in 2 weeks, right? You control the time, don't you don't control the results. And the rule two, define kill criteria upfront. If we can't beat 75% after 3 experiments, we pivot. This prevents endless optimization, right? And the rule three, separate data work from model work. Data tasks like ETL and labeling are predictable. Plan them like normal tickets. Model experiments are uncertain. Plan them differently. And the rule four, build in decision points. After each experiment, continue, pivot, ship, kill. The PM makes this call, right? And rule 5, communicate uncertainty to the stakeholders. We have 60% confidence. We will hit the target by Q2, not it will be done by March, right? So, honest uncertainty beats false precision. So, before we close, let me give you a cheat sheet for talking to stakeholders about AI timelines. Don't say it will be done in 6 weeks. Say we have our initial results in 3 weeks and a go or no go decision by week 6. And don't say the model will be 95% accurate. Say we are targeting 85% plus and will run 3 experiments to get there. And don't say we just need to plug in AI. Say phase one is data validation, which takes 2 weeks before we can even start the modeling, right? The pattern is like acknowledge uncertainty, provide decision points, and give ranges, not the promises. Your stakeholders will respect you more for honesty than for false confidence, right? And yeah, all right. Homework time. Three things before episode three. One, map your current project to the 6 phase life cycle. Which phase are you in right now? Are you skipping any phases? And take two. The second one is take one sprint ticket and rerate it is an experiment. It has an experiment ticket. Add a hypothesis, success criteria, and confidence level, right? And three is like for one AI feature you are working on or considering, what accuracy is good enough to ship? Write down the number and why. So in episode 3, we are covering how to talk to data scientists without sounding clueless. You'll get the exact vocabulary, the questions to ask, the questions to never ask, and the real conversation scripts, right? It's going to transform your cross functional relationships. If this is valuable, subscribe, hit the button, hit the bell button, and tell me in the comments what is the biggest challenge you face planning AI projects. I read every comment. I am Pranav. This is AI for product managers, and I'll see you in episode 3. Thank you.